All right, guys, welcome everybody. It looks like I'm going to be tied up second period today, so I had to make a video for the first lesson. So welcome to CPM Algebra 2, Chapter 1, Investigations and Functions. Chapter 1 is also going to focus on us learning how to build strong teams, learning teams. Together we will work to answer questions, explain and give reasons to support your thinking, ask questions and share ideas. Members of your team are your first resource. You're stronger together than apart. Now, I realize that last year was remote, so you weren't doing any teamwork sophomore year, but freshman year you were. I'm not going to eat up a bunch of video time going through roles because I'm not going to assign you roles today anyways, but I will remind you of what those roles are. So if you think back to freshman year, you could have been a resource manager, a facilitator, a recorder, and finally a task manager. If you have the chance, I would kind of just read through the team roles to remind yourself of them, because pretty much when you guys get assigned a team role, you're going to be in that role for the entire first unit. So keep that in mind. Okay, so you have that information for you. Okay. Ultimately, our main focus for today's lesson is going to be function machines. Okay, but before we look at the function machines problem / notes, because for A, I'm going to kind of talk about that one as notes. B, after you guys get done watching this video, is what you're basically going to be working on, okay, as some practice in terms of dealing with functions, but we're not there yet. So methods and meanings, math notes, functions, relationship between inputs. Now you got to remember that your inputs are your x's and the outputs are your y's. So a relationship between inputs and outputs is a function if there's exactly one output for each input. Another way that they word that is for every x there is one and only one y. Okay? Functions are often written as some expression involving x and y, where x is the input and y is the output. I already mentioned that. And then the following is an example of a function. Okay, so we actually have a quadratic there, or parabola, where they give you this equation. Okay, and last week you were working with your calculators, so you could pop in that equation, then access the table function, and then you would get the entire table. Okay, but if I didn't show it to you, this is how they're coming up with it. Theoretically, you can pick any number you want, okay, for x. So what they're doing is they're literally taking the equation y is equal to the quantity of x minus 2 squared, and then if you're picking -2 for x, you're literally plugging in. So you got -2 minus 2, which is going to give you -4 squared, which gives you the positive 16. So that's, if you're doing this by hand, that's where that 16 is coming from. And I'm not going to go through every single one of these. Okay, so if I were to do -1, I would have a -1 minus 2 squared, which would give me a -3 squared, which gives me a positive 9. and then that's where that 9 is coming from. But on Thursday and Friday, you guys were basically using your graphing calculator to get the XY table. Okay. But like I said, we're really not going to be focusing on graphing or coming up with an XY table today as much as what I did on the side, where you're given an input and you get those outputs. So this is an example above. The value of y depends on x, so y is called the dependent variable. Okay, and x is called the independent variable. So y depends on x. You can pick anything you want for x when you're making tables, and y depends on x. So another way to write a function is with notation, f of x instead of y. So what you should gather from this is that f of x is the same thing as y. The function named f has an output f of x. The input is x. And in the example at the right, f of 9 or f of 5 is equal to 9. The input is 5 and the output is 9. You read this as f of 5 equals 9. So when you're doing the function machines, here's your input with what you start out with, and then when you plug in and you get your answer, that's going to be your output. Okay, and that'll become a little bit more clear when I go back up to that other sheet. Okay, so the set of all inputs for which there is an output is called the domain, and the set of all possible outputs is called the range. Okay, so long story short, yeah, we are eventually going to be looking at domain and range. So if you don't quite understand this part of the notes, it's okay for now because it's not the focus. The focus is going to be this whole idea of you guys plugging in to get values, a certain output. Okay, so in the example above, notice that you can input any x value into the equation and get an output. The domain of this function is all real numbers because the number can be any input, and then the outputs are greater than or equal to 0, so the range is y is greater than or equal to 0. That's because if you kind of look at the parabola up top, okay, you'll notice that lowest point is at 0, and then if you were to look at all the y values, they're going to be greater than or equal to 0. And like I said, if you don't understand that, okay, not a big deal in terms of that for now, okay? And which brings us down to this thing. X squared plus y squared equals 1, which is the most basic equation of a circle, okay, is not a function because there are two y values outputs for some x values as shown below. So if you look at the table, you have a situation where -1 is 0 and 1 is 0, okay? And if you think back to the very beginning, for every x there can only be one y, while you have two x's here that have one y. And then freshman year you might have even talked about the vertical line test, okay, where if you were given a graph and asked if it was a function or not, if you drew a vertical line through it and it hit the graph in more than one spot, it was not a function. All right, but like I said, the most important part is going to be the actual function machine for today, but I wanted to review everything that was in there anyways. All right, so your teacher will give you a set of 4 function machines. Your team's job is to get a specific output by putting those machines in a particular order so that one machine's output becomes the next machine's input. As you work, discuss what you know about the kind of output each function produces to help you arrange the machines in an appropriate order. The 4 functions appear below. And then in your ebook, keep in mind that there are resource pages and that there are also going to be homework help pages. So keep that in mind. All right, so if we're looking at the first example, it says in what order should you stack the machines so that when 6, so 6 is going to be our input, is dropped into the first machine, all 4 machines have had their effect that the machine's output is 11. So we want to put in a 6 in one of those equations, get a result, and keep plugging into the other equations and until we get 11 as the answer is basically the train of thought. And again, there's no tricks to this other than trying to think ahead and keeping in mind that like decimals and fractions probably wouldn't be a reality for this because we're dealing with a square root in there. Not that you can't take the square root of fractions or decimals. All right, so I'm going to start off with k of x. So I got k is 6, and then I got a negative is part of that, divided by 2, then minus 1. 6 divided by 2 is 3, so I get negative 3 minus 1, which is going to give me a negative 4. Okay, so k is 6 is negative 4. Now what I have to do is take this negative 4 and plug it into one of those other equations. So, you know, I see that g of x, and again, I'm just working through there and seeing if I can get some number where it'd be easier to work with like the last 2. And sometimes it works, sometimes it doesn't. That's part of the problem solving thing. All right, so I got that negative sign out in front. So that doesn't disappear. Then I get a negative 6, and I got to square it. So I got a negative that's out in front, and then negative 6 squared is 36. All right, so right away you might get excited and think, oh man, I can take the square root of negative 36 because you recognize 36 is a perfect square. But then when we would try to do that, if I try to do f of negative 36, I get the square root of negative 36, which if I try it on my calculator, I'm going to get an error because remember, you can't take the square root of a negative number. That's when you get into what they call imaginary numbers, which is not the focus of the day. So what's the story here? Well, I ran into the wall, and then that means that I got to go back to the drawing board and try something else. So these problems are not meant for you to figure out in 5 seconds or less. You may have to try these more than once. So now let's see, I don't know, this time I'm going to start with g of x. So I'm going to try g of 6 is equal to, don't forget about that negative sign, 6 minus 2, quantity squared. So I get a negative 16. Okay, now when I'm looking at that negative 16, the only way that I can pretty much get rid of that negative is if I work with k of x. Because as I kind of ran into that wall, we know if we try to take the square root of a negative number, it's not going to work. So now I'm going to try to take that K and try negative 16 with it. So I got that negative, and then I got a negative 16 divided by 2, and then minus 1. So that negative stays out in front, okay? And then I get negative 16 divided by 2, which is going to give me a negative 8. Well, that's going to clear up and become 8 minus 1, which is going to give me 7, okay? So I know I don't want f of x because the square root of 7 is going to give me some decimal. So now I'm going to try to do h of 7. So I got 2 to the 7th minus 7. 2 to the 7th is 128. Minus 7 gives me 121. And then I recognize that 121 is a perfect square, so I did it correctly. Okay, so now I'm going to take the 121 and plug into f. So I do f of 121, which is going to be the square root of 121, and then I get 11, which is what I want, okay? Because that was the whole purpose of the directions in the problem. So for A, the particular order that I had to go in was I started off with G, then I had to go to K, then I had to go to H, and then I had to go to F, okay? So on B it says what order will result in a final output. Well, make sure you're reading because they start you off with the output and then the input is actually 64. So you're going to try to do the same thing with B and your group, okay? And reading is going to be very important because a lot of kids would not have read and then would have tried to start with 131,065, okay, when you're supposed to start with the 64. All right, have a good day, and I'll see you guys later.